Good afternoon again, students. The last class I introduced you to our number system, which is the Indo-Arabic system, and the other name of reference, such as the decimal system and the base 10. So they have three names that they call the same number system. The number system that we use, the Indo-Arabic, the decimal system, or the base 10. I also introduced you to the 10 main characters, symbols. There are many other symbols because it's a system. It's a group of things that come together. But the 10 main characters or symbols, we say we can make reference to them as numerals, and most important, the number or digits. Now from these 10 digits, we create other digits, right? As we increase in value, as we order things or objects in our everyday life. Right? So if you want to create, say, the number 10, you would take a 1 from the system and the 0 and create the number 10. And based from our understanding, this is how we write 10, because if we should change the place of each digit, we don't see it as 10. Because in our number system, we know that to write 10, we record it 10 like this. Similarly. But if you observe also how many digits that we use, we took a 1, we took a 0, and create the number 10. So the number 10 as in 2 digits. So numbers higher or greater than 10 are made up of digits. Similarly, if I want to create the number 23, I use a 2 and a 3 and I create 23. So in our number system, we know that this is how we write 23. The 2 comes first, then the 3. So the place of each digit is important in our number system, because if we should rearrange, we no longer have 23. We have a different number, which we know in our number system as 32. And 32 is made up of 2 digits out of the base 10 numerals or digits. So digits make up numbers. Similarly, if I want to make, say for example, the number 632, I take the 6, take a 3, take a 2, and I create the number 632. Now, this number 632, as we know it, we can use it to count objects in our environment. But this number, the position of each of these digits, because this number is made up of 1, 2, 3 digits. The position and the place of the digits is very important in our number system, because we know this number as 632. If we should rearrange it, any of these digits, then it's no longer 632. So the place and the location of each digit in a number is very important in our number system for it to maintain certain values. So once we rearrange, once they are not in, the digits are located in another position or place, then the value of the digits changes. Alright, so we use the symbols in our number system to create other numbers greater than 9. But importantly, digits make numbers, and the place where each digit is located in a number is very, very important. Now, why are these characters, symbol digits important? We use them in our everyday life, as we said, to organize our everyday life, to count objects, whether they are whole, such as a whole bun, a whole pack of biscuits, a whole case of juice, or they are pieces, like a piece of cake. So we use these digits to organize our everyday life by counting. So for example, I might have 1 die, 2 dice, 3 dice. But observe, we can use them to count the objects in singles, because 1, we have 1 die. 2, the character or the symbol or the digit 2 says that there are 2. So we are counting in singles or ones. I want 3 of this object, therefore then I have 3 singles, which makes up the character or the symbol or the digit 3. If I want 5 objects, it could be 5 mangoes, 5 chairs, 5 bags, then I count in singles. Alright? But our number system is so unique that we count from 1 to 2 in singles, and we organize the digits based on the position when we form numbers. Okay, earlier we said that if we want to form 23, we use a 2 and a 3. Right? And we know that 23 is written like this in our number system, because if we should change the place of the digits, we'd have a different number. That's no longer 23. So to maintain the value and to understand our number system properly, we create what's called a place value chart, which talks about the value of the digits in our number system. So when we're counting singles, wholes, we create our place value chart where, for example, 1, 2 object, 3, 4, 5, 6, 7, 8, 9. Now our place value system tells us that we count in singles, we place it under the ones place in our place values chart. Now once we go greater than 9 singles to get 10, so if we have 10 objects, we cannot place it under the ones column. We rename or regroup to get the value of 10, where it put the 1 here and the 0 here to represent the value 10, which this position is where we're counting by groups of 10s. Let's say we have this number 326. This number is made up of 3 digits, and it represents 326 whole objects. So for example, I may have 326 mangoes, whole complete mangoes. Now each of the digits in this number is very important in the place that they occupy, and the place that they occupy gives them the value that they maintain. So our number system creates the place value table or place value charts so that we can understand the value of our numbers. So this last digit in the whole number will always represent ones. Second digits going to your left represents tens, and this digit represents hundreds. So the value of each digit in a number is very important to the forming and calling of the number. Right, so in our number system, how did they create these number place value names? Remember, as we said, when we use the 10 digits in our number system to organize objects in our everyday environment, to count, and we usually start counting with singles from 0 when there is no object to 9, and when it reaches 10 we rename or regroup. So how do they move from ones to the tens? In our number system, we increase in value as we move from the ones position to your left. Because how do I move from 1 to 10? Some person may say we might have something. How do I move from 10 to 100? In fact, in our number system, the value of each digit is increased or multiplied by 10. So the value of each digit in our number system is multiplied by 10. So 10 ones, 10, 10, 10, 100, and so on to increase the value of the digit in our number system. But how do we represent numbers that are not whole numbers, for example, decimal numbers? There's provision for that in our number system place value chart. So once it's an whole number, we represent those digits on the left side of the place value chart. Once the decimal numbers, then we represent the digit on the right of the point on the right side of the place value chart. So how do I represent 37.8? We still have our whole number side where our number increased by 10. But on our right side of the point, the number decreased, which is divided by 10 in our number system. So hence, we have tenth. The place value names ends with th, hundredth. So we multiply by 10 to increase the value of the digits on the left, and we divide by 10 to decrease the value. So how would I represent 37.8? The 7, always the last digit is always ones, then 3 tenths, our point, then we have 8 tenths.